In today's lesson, we're going to be looking at integration by parts. So for our first example here, we want to take a look at the integral of sine 3x cos 4x with respect to x. And using integration by parts here, I did the following substitution. If you remember again, what you want to do is the integral of u dv is equal to u v minus the integral of v du. You want to use this relationship here. In this case here, I'm letting u equal the sine of 3x and dv equaling the cos of 4x with respect to x. And you can see here, obviously, this will create the exact question that we have and the question that we want to answer, the integral we want to evaluate. And we're going to re-represent it using integration by parts as u times v minus the integral of v du. So doing so gives us the following. We have the integral of u dv, i.e. our question, is equal to u times v. There's our u, and here's our v, minus the integral of v. Again, I just rewrote that v back down, times du, which is written right here. So now essentially this is our goal and this is our focus, is you want to go ahead and find this integral here. And you'll see here we have an integral very similar to the one that we started off with, except for now we have the sine of 4x instead of sine of 3x and cos of 3x instead of the cos of 4x. So what we want to do here is actually use integration by parts a second time. And using integration by parts a second time here, what we're going to do is I'm going to go ahead and take the u value to represent by the cos of 3x, and then I'm going to take the dv value and represent that by the sine of 4x dx. You can see here I took the quarter and the 3, I put those together and popped it outside of the integral sign. Again, those constant terms can come out of your integration symbols. Taking a look at this value here and going to do integration by parts on that. So when I rewrite this, you'll see what happens here. I'm going to go ahead and apply integration by parts on this expression, giving us the following. Applying integration by parts here, we have that the integral of sine 4x cos 3x with respect to x is going to equal u times v. So you can see here I subbed in the u, and I also subbed in the v value here. Minus, then we have the integral of v du, and you can see here I went ahead and substituted in our v value into here, and likewise our du value, I substitute that into here. So again, I've done integration by parts twice, but now what we've gotten here is the integral that I'm interested in evaluating now is the cos of 4x sine of 3x. And again, to remind you, I can take this negative 1/4 and this minus 3 and take that out of there. And that is exactly the integral we started off with in our original question. So watch what happens here. Again, cleaning this up here, we end up getting 3 over 16 cos of 3x cos of 4x plus 9 over 16 the integral of cos of 4x sine of 3x with respect to x. Now recall, this is equal to the integral of sine of 3x cos of 4x. So therefore, I now have an equation where the integral of sine of 3x cos of 4x is equal to this expression plus 9/16 this integral, but that is exactly what we started off with. So these are actually like terms here. So I'm going to go ahead and bring this 9 over 16th integral of our original question over to the other side, giving us the following. We end up getting 7 over 16. The integral of sine of 3x cos of 4x with respect to x is going to equal 1/4 sine of 3x sine of 4x plus 3/16. The cos of 3x cos of 4x. Divide out by 7 over 16, and we get our answer, which is the integral of sine of 3x cos of 4x with respect to x will equal 4 over 7 sine of 3x sine of 4x plus 3 over 7 cos of 3x cos of 4x plus our constant term c. All right, this is an example of using integration by parts numerous times within one question, and the goal is when you have these cyclic functions that kind of bounce back and forth between themselves, you're hoping that if you do integration by parts that second time, you can go ahead and get the same question you started off with, and then you can bring everything to one side and solve. So I thought I'd go through this example here. Thank you very much.